Hello, Bachu. Assalamu alaikum. So today we are just going to discuss actually the first chapter of our IGCSE and O-level syllabus. Before that, we just have discussed the basics of chemistry. So the very first chapter is going to be states of matter, in which you are like the students feel that's very easy chapter, and you're going to surely get the marking points. But there are some critical points that you have to take care of. Okay, like starting from the basics, I'll try my level best to revise the basics and each and every objective of states of matter, right? Now, see here, like states of matter is going to be solid, liquid, and gas, and matter, is everything, anything which, occupies space and, has some volume, right? Has some mass and occupies space, right? So it's known as a matter. Like we ourselves are, made up of matter. So matter, anything which has mass and occupies space or has volume is known as a matter, right? So if I'm just going to talk about it, what are the three basic, states of matter are going to be solid, liquid, gas, right? Solid, liquid, and gas. So here, like, if I do ask that, if you're just going to see that what is the difference in solid, liquid, and gas? So that is going to be the basic difference is going to be the arrangement of particles in solid, liquid, and gas, right? So we will be drawing the arrangement of particles, like how the particles are arranged in solid, liquid, and gas, right? So I hope that you could also, draw side by side. So that's solid, liquid, and gas I'm writing, okay? Now, see if I'm just talking about in solids, the particles are closer together, right? They are closer together and they're going to be arranged in the form of, like they're going to be arranged in the form of lattice, right? Regularly arranged. And to try to draw the same size of the particles, right? And try to draw in the form of lattice, okay? See, the particles should touch each other, right? They are closer together, okay? So I'm just not drawing the last one, okay? So this is going to be the particle, like the part arrangement of particles in solid, okay? So we say that the particles are arranged, there are three things. Okay, let's draw that first. So then they will be discussing three marking points, three things regarding that. So in the liquids, the particles are still closer together. They're going to be, you are going to draw same size of the particles, right? The particles are still closer together, but they are not arranged in the form of lattice, right? They are irregularly arranged, okay? And then in the gases, the particles are far from each other. Again, randomly arranged, okay? So this is like if the examiner is asking you to draw the particle arrangement of particles in solid, liquid, and gas, so you're going to draw it in that way, okay? Now see, but like if I'm going to say that, like how's the arrangement, motion, and separation? There we are going to discuss three things. That's going to be arrangement, separation, and motion, right? So if I'm just going to talk about the arrangement of the particles, like in solid, liquid, and gas, if I'm going to say that about arrangement, separation, and motion, right? So, whenever examiner is asking, like during the change of state, just describe these three things. So the students just describe about the arrangement, do not, describe about the separation. I'll also be showing you the actual candidates' responses, the actual scripts, so that you could just differentiate that how, the marks are being given. Okay, so how you're going to, why do we lose the marks in this? So arrangement, separation, and motion of the particles, right? So please help me, like how the particles are arranged in solids. So the arrangement is going to be regular or in the form of lattice. Lattice is regular repeated pattern, right? So in the solid, the arrangement of particles is the form of regular. And in liquids, the arrangement of particles is irregular or you can say random. And like arrangement of particles in gas is also going to be irregular or random. Okay, like they're not going to be arranged in any regular you can say that way pattern. Okay, if we are going to write down that the arrangement of particles in solids are going to be lattice, that will also go. Okay, that's also fine. Now if I'm going to talk about the separation of particles in solids, like that means the particles are closer together. Okay, usually the students choose the word tightly packed fine, it's fine. But they're just going to talk about the separation. Are they closer together? Are the particles touching or not touching, right? So better that you write down the particles are touching or closer together. In liquids also the particles are touching or closer together. They're not far from each other, still touching, right? And the gas, the particles are not touching. Okay? Like this particles are not, closer together. They're far from each other. Okay? Like if you're writing closer together, far from each other, that will also work. Okay. Like in the motion of the particles, you need to write down how the particles are arranged in solids, liquid, and gas, right? Like how the particles move, right? Now you know in solids the particles are arranged in the form of lattice in regular repeated motion, a regular repeated pattern. There is no, space. So how the particles will move? So they just vibrate at fixed position, right? So you can say that in the solids, the particles only vibrate at fixed position. In liquids, like there is some, space between the particles. So you can say that in the liquids, the particles slide past each other. Okay. So the particles slide past each other. And in gases, because of the very large spaces, the particles are far from each other, weak force of attraction. So you can say that the particles move randomly, right? Here and there, they can just move freely or randomly. Okay. So these are the three things, Bachu, that you should know: that arrangement, separation, and motion of the particles. Three things you have to write down even during the change of state. Okay. Now let's see the change of state, like when the solid turns into liquid. What do we say that? So I do ask, like usually most of you know that, just take the example of water, right? Like water, like in the solid state is going to be ice, right? When it turns into liquid, like when ice is left open in the air, like in the room temperature, so what happens? It turns liquid, okay? So what do we call this change of state? So this is going to be melting, right? All right. Now, we also have to discuss, Vijay, that is melting endothermic change or exothermic change? What is meant by that? Endo means absorbing the heat energy from the surrounding. So, what do you think? Like during melting, are the particles, absorbing energy from the surrounding and they are moving far from each other? Yes. Okay. So, we can say that melting is going to be endothermic change. Okay. I hope you're getting it. And the particles will move far from each other, and the force of attraction will be, will be weaker, right? Now, the change of state when liquid turns into gas is known as boiling, or you can also say that it's going to be evaporation. Okay. Now, there is a difference in boiling. There are the differences between boiling and evaporation. Boiling occurs at fixed temperature, and evaporation occurs at any temperature, below boiling. Boiling just occurs throughout the liquid, while evaporation is a surface process. Okay, and there are bubbles in boiling, and there are no bubbles in evaporation. Okay, so we know the basic differences between boiling and evaporation. Okay, and in the exam, if you write on boiling and evaporation, both will get the marks. Okay. Now, but you like, what is boiling or evaporation? Is it endothermic or exothermic? Now, see, the particles are moving far from each other. So again, they're going to absorb the energy from the surrounding and they're going to move far from each other. Okay. So we also say that this is also going to be endothermic change. Okay. I hope it's clear, right? Now, the change of state, when gas turns into liquid, there is also one process in which is known as sublimation. When solid turns directly into gas, that is known as sublimation. Okay, I'll show the marking points that there is going to be the change from 2023 till 2025 syllabus, and again 2026 till 2028 syllabus. Right now, see, um, when the change of state when gas turns into liquid, what do we call this change of state? Now again, see, when you have the gas, the steam, when you're going to condense it, when you're just going to cool it, so it's going to be converted into liquid. Okay, like if we're talking about water, so whatever was in the liquid state, when you're going to heat it, it's going to turn into steam, right? Now when gas turns into liquid, it's known as condensation. Okay, now we have to discuss what is condensation. Is it an exothermic change or endothermic change? Now see, this must have, release energy in the surrounding and the particles come closer to each other. Okay, so we can say that condensation is going to be exothermic change, right? the particles have lost energy in the surrounding, release energy in the surrounding, and come closer to each other. So we can say that condensation is going to be an exothermic change, right? When you're doing energy from chemicals, I will again revise this change of states, right? During this process, that's what happens. Similarly, again, can you predict what is when you're going to turn liquid into solid, right? So the change of state is known as, when you're turning liquid into solid, is known as freezing, right? Like when you're converting water into ice, so that is freezing. So what is freezing? Is it an exothermic change or endothermic change? Now see, the particles are coming closer to each other, right? The space between the particles have decreased, bacho. So that means this is going to be, like, we can say that freezing is also going to be exothermic change. It must have release and in this release energy in the surrounding, right? So we can say here that exothermic change. Freezing is also an exothermic change. Okay, I hope you got it. Now, what if the examiner is asking that describe the change of state during when the liquid, like solid, turns into like a solid turns into liquid? So what are you going to say? That in the solid state, the particles are closer together. They were arranged. The arrangement of particles changes from like regular to irregular. The separation of the particles changes from touching, and still the particles are touching, right? And motion of the particles changes from vibrating at fixed position to slide past each other, right? So make sure whether it's going to be of 2 marks or 3 marks, you need to write down all these 3 points: arrangement, separation, and motion of the particles. Okay. So this is one of the thing that we have covered so far in states of matter, right? Then the next part is going to be like heating and cooling curve. And what is the effect of, the temperature and pressure on on the gases? Okay, what happens to the volume of the gas when you're increasing the temperature or when you're increasing the pressure? Okay, so I hope this thing is clear so we can move further. Okay, just give me, like, I will just be showing you, Bacho, that the actual scripts, that how the students have got the marks. Okay, so give me 2 seconds. All right, I will show you 2 scripts in which the candidate has got 2 marks, and the script in which the candidate has got all marks, right? Full marks. Now, see here, describe the arrangement and motion of bromine molecules at minus 50 degrees Celsius. So that's going to be actually at the liquid state they're talking. So at minus 50 degrees Celsius, the molecules and bromine would be arranged regularly, right? So in a lattice, in a regular pattern, and as far as for motion, the molecules and bromine molecules are going to vibrate at fixed position, right? Actually, that's going to be in the solid state, right? It's solid, sorry. Okay. So it's going to be solid state. You need to describe arrangement and motion of bromine molecules at minus 50 degrees Celsius. So it's going to be, see the marking points in the lattice, in a, like, see the ticks, right? In a regular pattern, and for like the particles are vibrating. Now see what is the missing point, right? Just see. Now just compare this answer with this. Here there are 3 ticks, right? Molecules are arranged in a regular pattern, and if in a lattice arrangement, that's going to be the same marking points. Closely packed molecules vibrate at the fixed at their at their position, and the particles are touching each other. Now see, the third marking point is going to be regarding the separation. Okay, like this point the particles, molecules, or the particles are touching each other was missing over here. Okay, so I hope the students that you're just going to take care of these points when you're describing the states of matter, right? Now we're just going to move to the like effect of temperature and pressure on the motion of the particles, and also heating and cooling curve, right? And the next lesson, I will be discussing about this. What do you say that about um diffusion, right? So let's see. Right. Now, what is the effect of pressure on the volume of gas? When you're going to, the gases can be compressed. Okay. So what happens when you're just going to, compress the gases, right? So as you're going to increase the pressure, right? Um, on a gas increases, the volume of the gas decreases because they can be compressed, so the volume will decrease, right? What is the reason behind it? Because the gas particles are forced closer together. The particles are going to be closer together, right? Conversely, if you're going to release the pressure, like if you're going to decrease the pressure, right, the gas volume increases because the gas particles can move far further apart. That are going to be the marking points, right? Like when the examiner is asking in terms of kinetic particle theory, so when you increase the pressure, the particles will move closer together, right? Decreasing the volume. Similarly, if you're just going to, decrease the pressure, the particles are going to move far from each other, right? Here is the diagram which is going to represent this phenomena. Okay. So when you're going to, increase the pressure, right? So volume decreases. Okay. Similarly, when you're just going to, when you're going to decrease the pressure, the volume is going to be increased, right? So pulling up increases the volume and decreases the pressure, right? I hope you understand this thing. Now, other thing is going to be what is the effect of temperature on the volume of gas, right? So when you're going to increase the temperature, what happens? The particles are going to move further apart. They are going to move faster, right? And they're going to exert more pressure, and they're going to cause the gases to expand, right? Similarly, if the gas is cooled, the molecules will move more slowly, and the gas will contract or exert less pressure. In the other words, the volume of gas increases as the temperature increases if the pressure remains constant. Okay. Now see, here is a diagram which is going to, represent this phenomena. When you are going to, this is going to be the volume V1 at temperature T1, right? When you are going to increase the temperature, the particles are going to move faster. They're going to have more energy. They're going to move faster, and they're going to move far away from each other, increasing the volume. Okay. So I hope you understand the effect of temperature and pressure on volume of gas, right? Now we are going to discuss about heating curve, right? What happens in heating curve? You need to understand that during the change of state, right, the temperature remains constant, right? On x-axis, there's going to be heat added, and there is going to be, the temperature on y-axis, right? Like when you are going to heat a solid, the temperature rises. A fixed temperature where the change of state occurs, that's known as, when solid turns into liquid, is known as melting point, right? At that particular temperature, the temperature does not rise. Why? Because the temperature, the heat that you are, adding is used to overcome the force of attraction. Like it's going to convert all of the solids into liquid state. Okay. So the temperature will not rise. Now, the temperature, or you can say when all of the solid is converted into liquid, then when you're going to increase the temperature, then what happens? The temperature is going to rise. Okay. Now here we have liquid state. Okay. So when you're increasing the temperature, it will rise. Now the fixed temperature at which the liquid turns into gas, right, is known as a boiling point. Okay. Now at here, during the change of state, again, that there's going to be the line is going to be straight, because at that temperature, at that time, the temperature is not going to rise. Okay. Why? Because here again, the heat which you're adding is used to overcome the force of attraction. Like it's used to convert liquid into gas, right? When all of the liquid is going to be converted to gas, when you're going to increase the temperature, it will rise. Okay. But during the change of state, there will be no rise in the temperature, because the heat which is being added is going to used to overcome the force of attraction. All right. I hope you're getting it. Similarly, a similar phenomenon occurs when you're going to, remove the heat. That is known as cooling curve. Okay. right? So cooling curve also like is same, like when you are going to decrease, remove the heat, right? When you're going to cool the steam, then it's going to turn into liquid, right? And then when all of the liquid is going to be converted into gas, right? So when you're going to decrease the temperature at that point, at the vaporization, the temperature does not decrease, right? When all of the liquid is going to be converted, when all of the gas is going to be converted into liquid, right? Then when you're going to decrease the temperature will decrease, right? When you're going to remove the heat, right? That is going to be liquid state. Now the temperature, the fixed temperature when the liquid turns into solid, that's a freezing point. Okay. So at here again, there during a change of state, there will be no, decrease in the temperature, right? Because again, you're just going to remove the heat, so that heat is going to use, overcome the force of attraction actually. Okay? You're releasing the heat. The particles are going to move closer together. Okay? That is going to be opposite of heating curve. All right. I hope this heating and cooling curve and the kinetic particle theory is going to be clear to you, like how the particles are arranged in different phases, in different, states. Now, next point is going to be regarding diffusion, right? So what happens in diffusion? Usually the students say that the diffusion is going to be, diffusion is movement of particles from area of higher concentration to area of lower concentration, right? But actually what the diffusion is the mixing of particles due to random motion. Okay. So whenever examiner is asking us, okay, that what do you understand about the diffusion, so it's going to be mixing of particles due to random motion. Okay. Now, when or intermingling of particles, mixing of particles due to random motion, right? That is going to be the marking point. But when you're going to explain, like usually you might have seen when you are going to, ammonia and HCl are going to be mixed. So what will be their effect, right? So when you're going to, explain it, then you're going to say that it involves a movement of particles from region of higher concentration to the region of lower concentration until eventually they are going to have it, evenly spread it. Okay. You can say that at the equilibrium they're going to be equal concentration, right? Now it does not takes place in solid. Diffusion takes place in liquids and gases, right? Diffusion in liquids is much slower than in gases. I hope this thing is clear, right? So bas you just have to say that diffusion is going to be spreading of particles due to random motion. Okay. Now, see, another thing, that what factors affect on the rate of diffusion? Not all the gases diffuse at the same rate. Okay. Now, see, like ammonia and hydrochloric acid. Um, like if you're going to have ammonia over here, cotton wool soaked in ammonia, that's NH3, and here we have hydrogen chloride. Okay. So, or hydrochloric acid. So, what happens? There is going to be the particles of ammonia and particles of hydrochloric acids are going to, move together. They are going to mix, right, due to random motion until they are going to form ammonium chloride. Okay. Now, the thing is that why this white ring of ammonium chloride is formed over here. So, we said that not all the gases diffuse at the same rate. We just have to see the relative molecular mass. Okay. So the relative molecular mass of ammonia is lower than the relative molecular mass of hydrogen chloride or hydrochloric acid, right? So lighter the mass, more will be the rate of diffusion. Faster will be the rate of diffusion, okay? So we see that ammonia is the lighter molecule of two, so therefore it diffuses faster, okay? I hope it makes a sense, right? Now what happens, like if you're going to have, if you just take out the MR of ammonia is going to be 17 and MR of hydrogen chloride or hydrochloric acid is 36.5, right? So it's almost, double of it. So therefore, ammonia being lighter is going to travel faster. Okay. So therefore, it just is formed over here. If the difference of gases, like if it's going to be same, like if you just say that nitrogen, or you can say that carbon monoxide, so the rate of diffusion is going to be same. So if we could have mixed nitrogen and over here carbon monoxide, so being same mass, they must have diffused at the same rate, and the gas, like or the you can say that they could have mixed over here, okay, halfway in between. So if the difference of the mass is going to be the same, like if there is a equal mass, so they are going to travel the same distance. Ammonia being lighter in mass has traveled more distance. Okay? I hope this thing is clear, right? Now, a gaseous substance is slowly cooled at a temperature recorded every second. The results are shown on the graph. at which point is the substance solid. Okay. Now see, this is going to be the, like, you're just going to release the temperature, right? So here they're just going to take time on x-axis, and on y-axis there's going to be temperature, right? So what happens over here when you're just going to, release the heat? Okay. So here it's going to be, this is a gaseous substance. Over here it's going to be, when you're going to cool gas, it's going to be in liquid state. At B, we will have liquid as well as gaseous state, right? When all of the, gas is converted into liquid, then you will decrease the temperature. Here we are going to get, let me just write down over here. So at this stage, at here, at A, we are going to have gaseous state. Over here, we'll have both of you write down like this. Okay? The gaseous as well as liquid state, when all of the gas is converted to liquid. Now at C point, we will have liquid state. When the temperature at which the liquid turns into solid is going to be freezing point. Okay? So here, we will have liquid as well as solid state. Okay? Right? So this is going to be D actually. All right. When just see only solid, so there's going to be this. There's no option over here. So in D, we will have liquid as well as solid state. Okay. And that's the freezing point. Okay. I hope it makes sense, right? So let's discuss these questions. And with this, we will be through with our, states of matter, right? Element X can undergo the following physical changes. Right, so this is name each of the numbers physical changes shown in figure 1.1, right? So one is going to be like solid turns into liquid, is going to be melting, right? Second is when gas turns into liquid, is going to be condensation or condensing. Third is going to be when liquid turns into solid, is going to be freezing, right? Or solidifying. We usually say that freezing, right? Now, fourth is going to be like when liquid turns into gaseous state is going to be condensation. That's liquid turns into gas is going to be boiling or evaporation, right? Now, see, one of the difference between boiling and evaporation is the rate at which the processes occur. State another difference between boiling and evaporation. Make sure, like the difference which is already there in the stem of the question should not be repeated. Okay. So boiling and evaporation is the rate at which the process occurs, because boiling is going to be faster and evaporation is going to be slower. So what is another? It's going to be that boiling occurs throughout the liquid while evaporation is a surface process, right? Boiling occurs at a fixed temperature while evaporation can occur at any temperature below boiling point, right? Now see, describe separation, arrangement and motion of the particles of element X in solid state. So separation is going to be the particles are touching, right? Arrangement is going to be regular or lattice, and motion is going to be vibrate at fixed position, right? I hope this thing is clear to all of you, right? So these are the marking points. One more thing, I'll just be discussing at the end. Let's discuss this question as well. That's going to be, first, the diffusion depends on the relative molecular mass. Like lighter the particles, more will be the rate of diffusion, and also if you're going to increase the temperature, the rate of diffusion is going to be faster. Okay. Now, the diagram shows the diffusion of hydrogen chloride and ammonia in a glass tube. The gases are given off by the solution at each end of the tube. When hydrogen chloride and ammonia mixes, they produce a white solid, ammonium chloride. Which line shows where the white solid is formed, right? Now, here again we have ammonia. So, MR of ammonia is going to be 17. I'll also let you know that how we are going to calculate the relative molecular mass. So mass, like you can say that mass of nitrogen is 14 plus MR of hydrogen is 1, and there are 3 atoms, right? So when you will just solve it together, 14 plus 3 is going to be 17. Like how are you going to calculate MR of hydrogen chloride or hydrochloric acid? So hydrogen, AR of hydrogen is 1, right? Relative atomic mass or mass number. We'll be discussing further in detail in atomic structure in our next lesson, inshallah. So 1 and 2, there is only one atom of hydrogen, so 1 plus AR of chlorine is 35.5. In 2, there is only one atom of chlorine, so multiplied by 1, so that's going to be 36.5. Okay. Now see, it's going to be almost, a halfway of the it's lighter. Ammonia is halfway lighter than 36.5. Okay. So it is going to travel more distance, being lighter in weight. Okay, so as it's going to travel more distance, it's going to form over here. All right, C is just going to be halfway in between. Okay, now here if you would have got any lighter gas, so it has diffused more, right, more faster. Hydrogen chloride being heavier, it's just taken this much distance, right? I hope this thing is clear. Let me write down this equation, right? When ammonia reacts with hydrogen chloride, we are going to get ammonium chloride. Okay, so this is going to be the white smoke of ammonium chloride. Okay, I hope this um video was fruitful. I'll just show you quickly that the objectives that of states of matter, that how many objectives we have covered so far. So with that, I will just end the lesson. Okay, so just let me show you the objectives. So you could also be sharing, you should have the learner's guide. So whichever topics you're revising, you need to review through the learner's guide. Okay, so we just discussed 1.1. I will not read because you should not get bored. And then about the diffusion we discussed. All right, and yeah, right. So we have relative molecular mass. How are you going to find out the relative molecular mass? Let me just give you some work that I'll just again give you one more, example and ask you to solve few more, okay, to calculate the relative molecular mass, right? For example, if we have, a carbon dioxide gas, okay, and we have to calculate the relative molecular mass. What is the MR of this compound? It's going to be the sum of the total mass of the elements present in a compound, okay? So we'll just look at the periodic table and you'll find out that the carbon, like the mass number is 12, right? So 12, how many atoms of carbon that there are? Only one. So 12 multiplied by 1. Plus, before writing second element, you need to write down, plus sign. So the relative atomic mass or mass number of oxygen is 16. You have to see the bigger number. Multiplied by the two atoms of oxygen, so multiplied by 2. So when you'll just solve it further, so 12 plus 32, we will get 44. Okay? So we can say the relative molecular mass of carbon dioxide is 44. Okay? Now, you just need to calculate the relative molecular mass of nitrogen. You calculate the relative molecular mass of sulfuric acid, and also calculate the relative molecular mass of sulfur dioxide. Okay, so this is going to be your homework. Okay, so if you have done it, you could even share your responses. All the best. Take care. See you. Take care, Bachu. Bye.